Hello and welcome students. This is lecture number 3 on application of derivative. Let us solve few more questions on application of derivative. Right now we are taking questions on tangents and normals, that is application of derivative to geometry. See, question number 5 here is find the equations of the normals to the curve 3x square minus y square equals to 8 which are parallel to the line x plus 3y equals to 4. So I'm given a line x plus 3y equals to 4 is the line I'm given. The required normals are parallel to this line. Okay. So what I do here is suppose I have here a curve and the curve is say like this. Okay, I have a curve like this and there is a line. This is the curve. What curve is this? It is the curve 3x square minus y square equals to 8. This is the curve which is the given curve. Now let's go for the given line. The given line is say this. This is the given line. And what is it? Its equation is x plus 3y equals to 4. Now the thing is, there is a normal to this curve. There is a normal to this curve which is parallel to this line. So now, as we all know, students, that normal would be always perpendicular to the tangent, right? So here I have, first of all, I have a tangent here. I have a tangent to the curve. And this tangent is at this point. Now I draw normal to this curve. See why I need to draw the tangent? Because a normal will always be perpendicular to the tangent. So unless you draw a tangent, you won't be able to draw a normal. So now I draw a normal. See, I draw a normal. Now what is happening? We notice that this normal is parallel to the given line. You can check. This normal is parallel to this given line. You see this? The normal is parallel to the given line. What is the equation? They're asking us to find the equations of this normal. Now here, if you notice that in the question, they're using plural. It's plural, okay? Equations. What does it mean? It means the chances are that we have two normals which are parallel to this line. The chances are that this curve is such that there would be two normals parallel to this line, but we are going to consider just one. And if at all there are two, then we will get the two equations. We don't have to worry about it. So here we have, see, we have normal perpendicular to the tangent. Okay, so see, the first thing, if I have to find the equation of this normal, see, this is what I have to find the equation of. I want to find the equation of this normal. Okay, right, this is n. So if I want to find the equation of normal, what do I need? I need slope of this normal and I need 1 point on the normal. I need slope of the normal and 1 point on the normal. So what I do here is, see students, I write here this point, I write it as h comma k. I write that point as h comma k, and see how do I begin my solution. I write let h comma k be the point where the required normal is on the curve. Okay, so this point is h comma k. Now, what I will do is, let me differentiate this curve. The given curve is 3x square minus y square equals to 8. So I differentiate with respect to x. I get here 3 is a constant. Derivative of x square is 2x minus derivative of y square with respect to x is 2y into d by dx of y equals to 0. So here I get 6x, which goes on that side, minus 6x. So minus 2y dy by dx equals to minus 6x. So I got dy by dx as minus 6x upon minus 2y. Minus 6x upon minus 2y. This minus and minus is gone. I get here 2 1s are 2, 2 3s are 6. So I get here, see, so I get here dy by dx equals to 3x upon y. What I got? I got 3x upon y. Now what I will do is, see, I will substitute in this dy by dx, this the coordinate of point of contact. I will substitute this h comma k. Okay, if I substitute the coordinates of this point, then what I would get would be treated as the slope of the tangent. It would be treated as what? Slope of this tangent. Okay, so here I write here dy by dx at h comma k equals to 3h upon k, which is, this is what? This is slope of tangent at h comma k. This is the slope of tangent at h comma k. So if this is slope of tangent, what do you think is the slope of normal? What do you think is the slope of normal at h comma k? See, what I got here, 3h upon k is slope of the tangent. You see this, the tangent. So what do you think will be the slope of normal? It will be the negative reciprocal. I will write therefore slope of normal at h comma k will be, see, or normal is perpendicular to the tangent, so the product of their slope has to be -1. So if the slope of tangent is 3h upon k, slope of normal would be -k upon 3h. So it is -k upon 3h. I got the slope of normal. Okay, this is slope of normal. I write this as 1. Now check. Students, you got the slope of normal as -3k upon h. But remember one thing, that this normal is parallel to this line. You see this line? Yes. It is parallel to this line. If it is parallel, if the normal is parallel to this line, what does it mean? It means that the normal should have same slope as this line. When the two lines are parallel, see this line here, you see this line here, okay, is parallel to the normal. So as such, the slope of normal should be equal to slope of this line. I will write the slope of x plus 3y equals to 4. I'll write here slope of, slope of x plus 3y minus 4 equals to 0. Okay, x plus 3y equals to 4, that is x plus 3y minus 4 equals to 0 is, it is negative a upon b. What is a? A is 1 upon b. What is b? 3. So -1 by 3. Okay, slope of this. Now remember students that this slope and the slope of normal should be equal. Why? Because the normal is parallel to this line. I will write therefore negative k upon 3h, therefore negative k upon 3h equals to negative 1 upon 3. Okay, so this 3 and 3 will cancel, common denominator, and this negative sign will also cancel. So we will have, therefore, see, we will have k equals to h. What we are having? We are having k equals to h. This is first equation I got, k equals to h. Okay. If I get one more equation in h and k, I'll be able to solve the problem. So here we have got one equation in h and k. For the second equation in h and k, what we will do is, see, we will say that the point h comma k lies on the curve. You see this point h comma k is lying on the curve. So what will happen? Since h comma k lies on the curve, the coordinates of the point h comma k will satisfy the equation of the curve. Okay, so this is what I will write. I will write, since point h comma k lies on the curve, therefore h comma k will satisfy the equation of the curve. Therefore we can write, see, where in the equation of the curve, where I have x, I will write h, and where I have y, I'll write k. So the equation of the curve was 3x square minus y square equals to 8. It will look like 3h square minus k square equals to 8. Now what I will do is, I have two equations to be solved. See, I've got two independent equations in h and k. One equation is here 2, which has k equals to h for me, and this is the third equation. I will write using 2 in 1. That is, what I'm doing is, in equation number 3, where I have k, I'm writing h because k is h. So I get 3h square minus h square is 8. I get 2h square is 8. So I'll get h square as 4. So I'll get h as plus minus 2. Now since k is same as h, so if h is plus minus 2, so as k is plus minus 2. Now the points on the curve are, when h is, the points on the curve where the normals are drawn are 2, 2 and negative 2, negative 2. When h is 2, k is 2. So one point is 2, 2. When h is negative 2, k is negative 2. The other point is negative 2, negative 2. So the equation of normal at 2, 2. See, there will be two normals. One is at 2, 2. The other is at negative 2, negative 2. So first I'm finding the equation of normal at 2, 2. So what I'll have to do is, first then I'll have to find the slope of the normal at 2, 2. So here is the slope. See, this is the slope. Negative k upon 3h is the slope. So what I do is, I substitute here negative k, I substitute there I substitute k as 2 and h as 2. So I will get here minus 1 by 3. Okay, see, negative k upon 3h. So negative 2 upon 2 into 3, I'll get minus 1 by 3. So I got now I'll write the equation of the normal in slope point form. So y minus y1, because now I have a point and I have the slope. Point is 2, 2. So y minus y1 equals to m into x minus x1. So this is what I get. I get the equation of the normal to the curve at point 2, 2. I got it at point 2, 2. Okay. Then you have negative 2, negative 2, which you will all solve. You will all solve for negative 2, negative 2 on your own. So what you will have to do, so you will give the heading like this: slope of normal, equation of normal at negative 2, negative 2. get the slope at -2, -2 by substituting this. Okay, the slope will be same because they are parallel to same line. Slope will remain -1/3 only. Okay, see, the idea here is, students, you know what I did? I calculated the slope of the normal, and the idea is the slope of the normal, even if we had not calculated, we would have got it because the normal is parallel to this line and we know the slope of this line. Okay, so you can say that I missed it. Anyways, it happens, sometimes it happens. I will say once again what I'm trying to tell you. See what I'm doing, students. I found the slope of the normal at 2, 2, which I think was not required. Why it was not required? Because the required normal, as it is said, see, this is the required normal, this is the required normal, and this normal they have already given, it is parallel to this line. It is already given that it is parallel to this line. So if it is parallel to this line, the normal would have slope same as this line slope, and the slope, the slope of the line is -1/3. So even if we had not calculated, see, even after calculating, we are getting -1/3. So that was not required. Okay. So we will not calculate for the second one. That is, I will write the equation. I will directly find the equation of the normal. Okay. So here I write here equation of normal at -2, -2. What will that be? Equation of normal at -2, -2 will be as follows. See, y minus y1 equals to m, that is -1/3, x minus x1. So I have y plus 2. We multiply 3 here and negative x plus 2. So we got y, 3y plus 6 equals to negative x minus 2. So we have x plus 3y plus 8 equals to 0. X plus 3y plus 8 equals to 0. This is the equation of normal. Equation of normal at -2. Now we have another question here. See, the question here is, if the line y equals to 4x minus 5 touches the curve y square equals to ax cube plus b. So think there is some curve. Okay, any curve. It could be any curve. Okay, so think there is some curve. Y square equals to ax cube plus b. So this is the curve here. I write this as y square equals to ax cube plus b. This is just a rough sketch for representation purpose. So remember that it has got nothing to do with the actual curve. The curve could be some other curve, may not be this curve. So this is just for the sake of understanding. So y square equals to ax cube plus b. I have one curve. They say this line, if the line y equals to 4x minus 5 touches the curve, so this line is touching this curve. Okay, so I understand that this line is a tangent to the curve. So I draw a tangent, and what is the equation? It is y equals to 4x minus 5. Okay, they say it is tangent. It touches the curve at the point 2, 3. Now they have given us the point where the line is touching the curve. The point is 2, 3. The point is 2, 3. Okay. They're saying find the value of A and B. This is extremely easy question, students. This is very simple question. We will simply follow the pointers which I have explained you, and we will get the answer. See, the first thing, we will go by our concepts. We know that whenever I differentiate the equation of curve and I get dy by dx, okay, and in that dy by dx, when I substitute the coordinates of a point which is on the curve, I always get the slope of the tangent to that curve at the respective point. So here I write the given curve. The given curve is, what is the given curve? It's y square equals to ax cube plus b. I write here differentiating with respect to x. So I get here d by dx of y square, that is 2y into d by dx of y equals to d by dx of this. A derivative of x cube is 3x square plus 0. A into 3x square plus 0. So we get here, therefore, dy by dx equals to 3ax square upon 2y. 3ax square upon 2y. So we got dy by dx. Now in this dy by dx, remember students, when I substitute 2 comma 3, when I substitute 2 comma 3, what do I get? I will get the slope of the tangent to the curve at 2 comma 3, right? So let me substitute in dy by dx, let me substitute 2 comma 3. So here I have 3a into 2 square upon 2 into 3. Got that? Upon 2 into 3. So this 3 cancels this 3 and this 2 will cancel 1, 2. So I got 2a. And what is this 2a? So I will write, therefore, slope of the tangent, slope of tangent to the curve, which curve? The given curve, to the curve at 2 comma 3 equals to 2a. But mind it, students, that the tangent at that point has already been given to us. What is the tangent given to us? The tangent, they say, at 2 comma 3 to the curve, the tangent is this. I will write here, the tangent at 2 comma 3 is y equals to 4x minus 5. Now see, it is in the form y equals to mx plus c. This equation is in the form y equals to mx plus c. So definitely you have the slope as m. You see this? So I will write, therefore, the slope of tangent, therefore slope of tangent is 4. But I found the slope of tangent to be 2a. So I'll write, therefore, 2a equals to 4 and a is 2. Remember, students, with the help of derivative, see, you differentiated the curve, you got dy by dx. In the dy by dx, you substituted 2, 3. After substituting 2, 3, what you got is the slope of the tangent at 2, 3. So you got the slope of this tangent itself. But since you know the equation of the tangent, you already have the slope of tangent. So you equated 2a with 4 and you got the value of a as 2. Now what you will do? You have to now find the value of b. How will you solve for b? Write this equation as equation number 1. See, I write using a in 1. So we will get the equation of curve as y square equals to 2x cube plus b. Okay, remember, students, to get the value of b, I will write 2 comma 3 lies on the curve. So 2 comma 3 will satisfy the equation of curve. What I will write? Point 2 comma 3 0.2 comma 3 lies on the curve. It lies on the curve. Therefore, 2 comma 3 will satisfy, it will satisfy the equation of curve. Okay, therefore we get, okay, I'm writing here only. Therefore we get what you get in the equation of curve, students. In the equation of curve here, let me write x as 2 and y as 3. X 2 comma 3, right? So I get here 3 square equals to 2 into 2 cube, 2 into 2 cube plus b. So I got here 9 and here I got 16 plus b. So b equals to -7. So students, we got the value of a as well as the value of b. We got both the answer. I hope you followed it.